was 14. The second person was better each time.
And that, Skylar brings up, I hadn't thought of this. But there's a potential sample bias based in how we did our experiment, isn't there?
The second person
Is probably going to be slower because the first person, I'm guessing what happened with me and Tim and what Skylar's agreeing to here, and Cameron also mentioned to me, the first person watching the first experimenter watching the first experimentee goes, holy crap, they're thinking it's really fast. And then maybe you slow it down in your mind. So an ideal would be to automate the whole process and give you all like some kind of an app where you could, like it's a stopwatch on your phone, but then you have to watch it yourself. You'd have to do it with a third party, like a third party computer program keeping track of it for you. You couldn't track yourself because that's what I was trying to do with the stopwatch facing away from you. But something better or more interesting is the bias introduced by the second person. Or just not switch, just use half the data points. We could just use the first people that went, but what happens there?
Or do it at the same time.
We could just...
your sample size.
Oh, that's good.
Each do it at the same time and say, okay, write it down.
We could, twice as many stopwatches and/or cell phones. That's good though.
Or you have to do cell phones.
But hang on, time out. Why? I want to go back to this using half the data points. What's the problem with doing that? I love your idea, Kate, I do. Smaller sample, which means larger margin of error, less precision. So if we can sacrifice precision for maybe less bias, that's a question we're going to deal with starting next week. I promise you that. That's a great question. What would you rather have, a less type 1 or a less type 2 error? And this is good. I think we're bringing it up right now. We're not going to worry about it right now. Let's use all the data points. It'd be fun to see all these little correlations. It'd be fun to see a correlation. Maybe what we should do. Yeah, grab your median of your 5 measures right now. I'm trying to think if we should arrange them so we go all the first people, all the second people, and then check it. Yeah, let's do that. Let's put them all together first.
But it really depends on what the first person's mistakes are.
That's true. Were they fast? Were they slow? Let's just see if there's a difference. Let's just see. So friends, let's do this to collect the data. Brandon, would you mind? Thank you, sir.
I'm confused. Why would we be using not just use the average? Why would we average them?
Well, you could average them too. The median's easier to find.
Is it?
Well, the average you have to put all 5 in and divide by 5. The median just look for the
more
middle.
accurate.
That's fine. I don't think it makes that much of a difference. Just grab the median. It's easier. I mean, you can do it both ways and see if there's a difference. That's a fun little project in and of itself. So let's go in. Let's do this. I'm going to go around the room and ask for the people who went first as experimentees and get all those times. And then we'll put the experimenters after. And we'll run it 3 different ways. We'll run it as, yeah, I think we can do this. So, Tim, you went first. You were 5.56. That was your first value. Oh, actually, let me clear first. So 5.56. Over here, which one of you guys went first?
She went first and I did. 11.26.
11.26. Love it. 3.87. This is fantastic.
Wow. 8.53.
8.53.
Oh, 14.5.
14.5. This is freaking awesome. I was kind of hoping this would happen.
5.81.
5.81.
8.60.
8.60. Love it.
9.98.
9.98. What's up, Miss Romano? 7.15.
Don't make fun of me.
You got 6.44. That works if you can say Mississippi in a second, which I can't, obviously. Who's over here? Did I get you, Michael? Did I get Cameron?
9.7.
9.71. Machines over there. You guys?
10.06.
Woo! One more for you guys?
7.93.
Okay, 7.93. Now, remember the 7.93 was the last. Let's come back around and grab the second people, and I think I can do this, we can clean this up.
You started with 10.
I started with Tim. Tim, go ahead.
Yours was 8.22.
8.22, I suck.
Oh, do you want that? You want that now too, don't you?
No, I want to copy the list, and then I don't know how to augment lists, because I want to do all of them together first,
okay.
and then split them up. So I think I have a method for this, I think. You guys? 9.87. Woo!
9.79.
Woo!
12.15.
Mm-hmm. Where's you guys?
10.31.
10.31.
Dang.
9.32.
9.3. Whoops. 32.
data is already getting
This is why I want to look at both of them. Yes, I'm kind of excited to look at both. You guys up here?
6.22.
6.22. Love it.
11.06.
11.06. Tim, I got you already. Go ahead.
8.77.
7?
9.97.
I don't know why I'm making these noises.
8.41.
841?
Yeah, 9.41.
9.41.
6.22.
6.22.
8.79.
8.79. Is that everybody? Okay, so what I'm going to do is I'm going to copy those into L2 and L3. And now what I'm going to do is I'm going to make L2 be just the first people, which stopped with 7.93, right? So I'm going to get rid of all these. This is kind of manky way to do it, but there's a command called augment, which I've completely forgotten how to use, which would do this for me much more quickly. Okay, and now this list, I want to have everybody except the first people, so I'll delete up to the 7.93. Okay, delete, delete, delete. Somebody stop me before I screw this up. Delete 7.93, right?
Yes.
Okay, good. Okay, put it down. All right, now I'm curious. How do we do? How do we do? Okay, so estimating 10 seconds. And we're going to do 3 different 95% confidence intervals. 3 different ones. We're going to do the whole class.
Were we supposed to be putting that on our computer?
Well, if you didn't, we've got to go to video and do it later. Or I can give you the data before you leave and you can practice at home. So whole class, first experimenters and second experimenters. But if with your permission, what I think we should do first is make box plots of all 3 of them and see how all 3 box plots look. Because now we have continuous data, we can actually graph them. Like with binomial data, it's boring. It's 1 or a 0. You can't graph anything. It's a percentage. But let's turn 3 plots on. Let's turn the box plot for the whole class, just the first and just the second. So in case you've forgotten how to do this, and that's totally fine, you want to go to, let me zoom this in too. Yes, you want to go to second y equals, stat plots. And we're going to turn each one of them on. So plot 1, turn it on. Make it modified. I'm curious if we have any outliers. Because there might be some unusually large or small data values that maybe we should can. Maybe. I try to take care of that by using the median. That was one of the reasons using the median. Maybe then we strip the outliers before they become outliers. But let's just take a look. So for plot 1, we'll use L1. That's the whole class. That's the whole class. Second y equals again, plot 2. Let's do L2 and 1. And with this will be just the first people that went. We'll see their times. And then plot 3 will be, yeah, actually that's set up correctly, L3 and 1, at least on mine it is. So the top, I think it's going to go top, middle, bottom, whole class, first experimenters, second experimenters, I think. I'm going to check to make sure nothing's in the way. Everything's good. Zoom 9. Okay, look at that. We do have a potential high outlier in the whole class. I'm assuming that's the whole class. Let me look real quick. Trace. Yeah, that's the whole class up top. This is just the first experimenters and this is just the second ones. So check it out. We had a theory, didn't we? We had a theory that these folks were going to get slower than these folks. On median, it looks like they did. Now whether that's meaningful or not is up for analysis. Because yes, median is higher, quartile is higher, max is actually lower. But a lot of these measures of relative position are higher. The question is it significantly higher or significantly different than the entire class as a whole? The only way to answer that, and when I say significantly, I don't mean practically significantly. I mean statistically significantly. Practically significantly would mean that there's some kind of a contextual attachment, like a half a second means something. I'm talking about statistical significance. Do the intervals overlap or not? If they don't overlap, there are significant differences. If they do, there aren't. That's what I'm talking about. We can get in fistfights all day long with practical significance. And since you all kick my ass, I don't want to get in fights with you. But statistical significance, it's either do the intervals overlap. I'm putting some more black and white and less gray into it that way.
Well, they do overlap, but they're smaller.
The kicker is, these aren't the confidence intervals though. This is just the raw data. This is descriptive, we need to make it inferential. So we have to treat ourselves as random
But it
samples.
still seems like the second group works.
Well, let's find out. Let's find out if it holds up under inferential analysis. I like that, D. Let's see if it holds up. I don't know the answer to that. So let's run a t interval for each of the 3 and then analyze. Yes? So stat tests, do we leave the outlier in the first one, do you think? Or pull it out? It's gonna pull the average a little bit, isn't it? Is that okay? Did you catch how it's an outlier here, but it's not an outlier here? That's the same data point. Isn't that interesting? It's an outlier in the initial, but it's not an outlier in the second. That's just a function of how outliers are calculated. Leave it in?
Yes.
Cool. Totally fine with that. I would do the same thing. T interval. Okay, this is already set up to go for the whole class. So when I ask the whole class to estimate 10 seconds, I am 95% confident that you're going to get at least 7.9 seconds, maybe as much as 9.76 seconds, which means I'm 95% confident that you're underestimating 10 seconds as a class. I asked you to find 10. On average, you're just shy of it. Now, there is a minimum difference between that 9.76 to 10, 0.24 seconds, a quarter of a second. Some people will argue that's meaningless. Okay, I'm not going to argue that point. It might be practically meaningless. Maybe a quarter of a second is practically meaningless, but it is statistically significantly different. It is statistically significantly at least a quarter of a second different. Do you see the difference between those two things? It might not be that a quarter of a second means squat, but statistically significantly there is at least a 0.24 or a quarter of a second lag in judging where 10 seconds is on average and where 10 seconds actually is chronologically. Fair enough? Let's test everybody else. Let's test T intervals. Now what's going to happen with this one? Yeah, what's going to change?
Your list.
But what's going to change overall? Well, define everything.
I was just trying to give you something.
You're trying to give me something. Thank you, I appreciate that, Megan.
Your sample size is going to be smaller.
Sample size is smaller, which means
Larger margin of error.
larger margin of error. And that's kind of what Megan was getting with everything. I appreciate that. Here we go. Here's the first experimenters. The first experimenters have an average 6.7 up to 10.1. You can see that margin of error difference. You're spanning, what is that? You're spanning essentially 3.5 seconds, where the top one spanned roughly half of that, which makes perfect sense. Makes perfect sense. Now, you have to remember too, in the first one, with the whole class, I can statistically significantly say that you're underestimating 10 seconds. Can I say that with just the first experimenters? Gesundheit, I can't anymore. And how come? Right, because 10 seconds is actually in the interval, which means I'm 95% confident it's between 6.7 and 10.1. It could be over 10. Granted, that's a tiny part of the interval. And Michael asked a great question last time about, well, just chop the confidence down. Well, you could do that. But at 95% confidence, I can't claim it's not 10 anymore. I can't claim it's not 10 anymore. How about the last one, which was the second? Data L3. All right, and how did you guys do? You are between 8.2 and 10.3-ish. Is there any difference statistically between the first experimental group and the second experimental group? Not statistically significant. Margin of error changed. But now some of you might say, wait a minute, time out, damn it. How did the margin of error change if they have the same sample size? Sample size is only part of the calculation. There's also a standard deviation that's part of that calculation, which obviously was different for the second group than the first group. All this tells me is I can't tell a difference between the two groups. Yes, the average of this one is higher, but it's not statistically significantly higher because the margin, the fishy in this tank can be down to 6.7 up to 10.1.
Well, all three sets overlap.
Essentially, I can't tell a difference statistically significantly between all three groups. The only way, if there was a difference, would be to do what?
Have more samples.
Replicate the experiment again, get more samples, drive the margins of error down so the fish tanks get small. Right now they're doing this, yes?
Yeah.
If you truly believe there's a difference, go get more data until they do this. There's no guarantee they will. But that's the only way to figure it out. See what we're getting at, friends? Excellent. Thank you for helping me design the experiment. It's fantastic. We'll see you on Monday. We got one more experiment to do. We're out of time. So we'll do it on Monday. If you don't mind. Appreciate it. Yeah, I got a little stopwatch bucket up here. Thank you guys. Have a good weekend.
But thinking about holding it, but both doing it at the same time.
Yes.
Then you can count in a second with your